This unit is hopefully just a repeat of the last unit. All we're really doing is adding one more kind of step to it. So a lot of the basic reaction mechanisms that you saw in the last particular unit is about the same here. So in these two chapters, we're talking about nucleophilic addition again, but it will swiftly be followed by an elimination, which means that you have to have a leaving group in your structure to start. So where these typically get referenced is with compounds known as acid derivatives. So if we write that out, acid derivatives, that says derivatives, you can trust me. If we look at a carboxylic acid, we have kind of a leaving group there, but that leaving group is awful. So what we'll do as a derivative would be just change the leaving group. Instead of it being an OH, we'll make it a Cl. It's still maintaining that kind of same characteristics. We still have an electrophilic carbon. That's why the nucleophilic addition happens. But the big thing that changes is we now have this leaving group. And so really all we're talking about here is the acid derivatives and what makes them different, and kind of how that chemistry interplays with the nucleophilic addition that we talked about in the last unit. So we've got two example mechanisms shown out here on the screen. We've got the word description behind what's happening within a nucleophilic addition, showing that general reaction. Note your nucleophile comes in, attacks the electrophilic site. Nucleophile, electrophile. Okay, so we're getting the nucleophilic addition. Okay, the subsequent steps would be the reverse, which would be the nucleophilic elimination. Get it? Get it? If I wasn't drawing, you'd see a goofy, stupid face. Okay, we're running the reverse of an addition. We're going to do an elimination. In that elimination, we need to be forming a pi bond, so our lone pair electrons come in, and then we would eject a leaving group. And yeah, I color-coded that backwards. Okay, so electrons come in, and then our leaving group leaves. The mechanisms that I chose to show here are familiar to you because we saw this when we did the nucleophilic addition with nitrogen to our carbonyls. Okay, and we were forming our imines, which is the structure shown at the bottom. Those mechanism examples were carefully selected so that you didn't kind of pigeonhole this whole reaction sequence into just acid derivatives, because the nucleophile addition followed by a nucleophile elimination are two separate mechanisms, but when we use them for acid derivatives, they're often referred to as this one piece. So we're combining those two things because all of those pieces are present. Okay, so we're starting with a polar pi bond with a leaving group. If we do the basic breakdown on the pieces behind this, we are going to use a nucleophile. Most of the nucleophiles we're going to use are going to be strong, so they are going to be negatively charged, though that can change depending on our electrophilic site. Okay? That carbonyl, just like with our last unit, is still electrophilic because we have that polar pi bond causing the electron density to move away. So what we're doing is running our addition reaction in that first step. Okay? We would then form what is known commonly, sorry, I wanted a different color there, as the tetrahedral intermediate. Before you get all lost in being like, why are we inventing new names? This isn't a big deal. It's the tetrahedral intermediate because the carbon in the middle is now tetrahedral. It started trigonal planar, it ends trigonal planar, and it's now tetrahedral with four things connected to it. That tetrahedral intermediate and ultimately some of its stability is what explains some of the reactivity that we go through and see later on. Right? That reactivity kind of goes back to the three groups connected to it. Those three groups are all typically electron withdrawing because of their electronegativity. Because of that, that center carbon starts to want electrons, so it starts to pull electrons back. The easiest place to pull them in this general mechanism is from that electronegative, or from that negatively charged oxygen. That now exceeds the octet, and we would eject the leaving group. Right? And we've now completed the elimination. Okay? So the elimination reaction, based on what I've been seeing in class, is a little bit more challenging for students because it's all happening in one thing. You're not bringing in multiple pieces. It's all kind of self-contained. We don't have a nucleophile label. We don't have a leaving group, or not leaving group. We don't have electrophile, any of that kind of labeled, because it's all intramolecular. Right? That's kind of the basics of the whole system. Right? The rest of this unit, which I think is going to come in about 12 lectures, is really just saying, well, what happens if this is the nucleophile? What happens if this is the nucleophile? And we're really just kind of nuancing some of those subtle differences in each of those stages of the overall mechanism. There are a few that you really do need to commit to memory, and I will call attention to those when we encounter them. The big kind of next piece to put in is that we're going to see those leaving groups. Right? The leaving group kind of substitution, these are all really in reference to our acid derivatives. Right? Our acid derivatives, there's a few more potentials, but these are kind of our core, if you will, acid derivatives. And in each of these cases, all we're really doing is modifying that piece. Okay? And in this case, I'm trying to get you to shift and keep your focus always to the right, and the left part is the part that stays the same. It becomes kind of relevant when we look at the anhydride because there's 2 carbonyls. Okay? But that's what we're trying to get you to see, is that we're just modifying the leaving group. So one of the things that you should be considering right about now would be, is this order that is getting presented to you random and arbitrary, or is there some other kind of underlying meaning behind why they are structured in this particular fashion? Okay? I'm going to leave that to you to consider because I don't think I reveal the answer yet because this is just our overview video. Okay? So, interconversions, this is our big kind of reaction scheme behind this, is that we want to be able to interconvert between these individual derivatives. So this slide, if we were in person, shows up in virtually every lecture because I want you to be constantly thinking of it. Because it's online, I'm just going to assume that you're going to go back and review that content. So please, if you aren't reviewing it, make sure you key in on this because this is a really important slide because it allows you to interconvert between those individual pieces. Okay? Some of the big points to note here, that these reaction arrows, for the most part, are not equilibrium arrows. And that does make things kind of important. For instance, if I were to say be this structure, I can't go from that structure to the acyl chloride. It just doesn't work. Okay? But what I could do would be stepwise move to the acid. Then in a second step, I could move to the acyl chloride. Okay? So this structuring has a lot of kind of embedded information behind it. Okay? Yeah, we'll leave it at that because we'll address kind of the details behind this later on. This is a big kind of overview of all of the reactions that are kind of going to be discussed. In this case, it's focusing on the acyl chloride, which is that middle structure. That's our acyl chloride. And we're looking at all the different ways that we could react the acid derivative. Okay? Most of what we're talking about as far as this unit goes is we then go through and say, well, we can get rid of the acyl chloride and we can now make it the anhydride. How does that change things? Okay? Because it's kind of repetitive and redundant chemistry, I don't go through a whole bunch of that detail. I leave that to you to kind of explore. Where there's big differences, I call out those and say, hey, we need to look at this because of this reason. Okay? But for the most part, all we're doing is putting the next one in and spider away. Okay? So this kind of spider is going to be useful because it summarizes all of those big reactions that we'll address in this unit. The next one, oh my God, crazy. We looked at pieces of this before. Okay, what this is really kind of trying to do is address all of the reactions associated with the keto-enol tautomerization. Because remember, that creates a nucleophile. That nucleophile could now react in a myriad of different ways. Ultimately, it's the same way all the way through, but we see all these reactions and freak out. It's the same idea. You create a carbon nucleophile, and now you react it with an electrophile. In the case of the aldol, they were centrally located. When we move out to the claisen is the aldol reaction, except instead of it being an aldehyde and a ketone, it's now an ester. That's going to change the chemistry, kind of, sort of. In my opinion, it doesn't change it at all, and I think it's dumb that we associate a name with it. Okay? I'm definitely unpopular in that. That's okay. Right? The chemistry is all still the same. Focus on what's happening, find those negatives, find those positives, and start putting those pieces together. The more you can start to connect reactions from this unit to the reactions of the last unit, the more likely you're going to retain the content from both units and do better in ultimately the whole course, because this is now 2 units worth of stuff. Okay? And then where we will end, which is of course obnoxious, I want you to go through, and we've got 5 reactions here. I would like you to go through and attempt these. Okay? I know we haven't really covered any of the whys or the hows, but again, it's repeat of the old stuff. Okay? So go through, attempt these. We've got the discussion board. Post your answers to the discussion board. Email me if you don't want to do that. That's okay. Some of these are much more challenging than others. I want you to struggle through it and see if you can find where those connections are already falling and how you could improve or change things going forward. Okay, so with that, we are done with that first intro video. Thanks for watching, and we'll see you soon.